So this video is part 2 of the rational functions practice sheets. All right, so it's the same idea. Now as we get through this, some of them will become a little more complicated, but we're going to take you step by step, so please don't worry. All right, again, same problem as last time, same types of problems as last time. First thing you do is factor and then cancel. There's nothing to factor for these problems, so we can skip that step. We can go right into the y-intercept. So if that's our equation, we put zeros in for the x's, so we got 0 minus 3 over 0 plus 4. If we reduce the fraction, or simplify the fraction, you get 0 comma negative 3 over 4. We'll plot this point on the y-axis. Next we go for the x-intercept. You take the numerator, so the x minus 3 is equal to 0. Solve for x, you get 3 comma 0. All right. For the vertical asymptote, you take your denominator, x plus 4, set it equal to 0. Solve for x, which will be x equals negative 4. Put your dashed line vertically. For a horizontal asymptote, we take the first two terms, the leading terms, so we got x over x. If you reduce that fraction, x over x, you get y equals 1. Put our dashed line at 1 going across. Since we didn't cancel anything out, there are no holes. All right, now we look for our sign analysis. Well, we have 2 points on the right side of our vertical asymptotes. We need to find something on the left. We like 5, so let's put negative 5 in there. So we're going to put negative 5 minus 3 over negative 5 plus 4. Which will give us negative 8 over negative 1, which is positive 8. So negative 5 and positive 8 would put our point right here. Now with our points, we can draw the line through the points and bounded by the asymptotes. Excuse me. All right. There's the first one. Number 2. We can factor this. There's a greatest common factor out of the top. You can take out a 3. You're left with x minus 2. On the bottom, you're left with x plus 2 and x minus 2, if we factor it correctly. Cancel out the x minus 2s, we'll be left with 3 over x plus 2. All right. So for the y-intercept, we put zeros in for the x's. So we have 3 over 0 plus 2. Reduce that or simplify it, you get 3 over 2 as your y value. So that's 1.5. So we go over here. About there is our point. For the x-intercept, we take the numerator, so we have 3 is equal to 0. Well, that's not true. That's not a true statement. 3 does not equal 0. That means there are none. There are no x-intercepts, because it's not a true statement. Vertical asymptote. Take your denominator, set it equal to 0. X will equal negative 2. So at negative 2, we put in our asymptotes. For horizontal asymptote, we have 3 over x, the leading coefficients, or the leading term, sorry, of our equation. Okay. Again, as with the last sheet we had, when we had a number over an x value, it's a number being divided by a really big number. So 3 divided by 1,000,000,000 is really close to 0. So we have y equals 0. Your holes, we cancel out x minus 2. So we set that equal to 0 and solve. We get 2. Okay. Now we put that back into our equation. 3 over 2 plus 2 is equal to 3/4. So we have 2 and then 3/4. That's our hole about there. All right, for a sign analysis, we have 2 points, or actually we have a point and a hole on the right side of our vertical asymptote. We have nothing on the left. So we'll put in our negative 5 again. We put negative 5 in. We have 3 over negative 5 plus 2, which is 3 over negative 3, which is negative 1. Right here. There we go. Oops. Or if now again we go through the points, don't go through the hole. If you put the line through the hole, it's technically wrong, so please don't do that. There we go. All right, number 3. We factor our equation. We have x plus 2 and x minus 1 on the top. On the bottom, we have x minus 4 and x plus 2. X plus 2's will cancel. We'll be off with x minus 1 over x minus 4. Okay, so that's our equation. We're going to use zeros in the x's for the y-intercept. So we got 0 minus 1 or 0 minus 4 gives you positive 1/4. So points right about there. For the x-intercept, we have x minus 1 equals 0. Again, we're taking the numerator, setting it equal to 0. So we have 1 comma 0 as our x-intercept. For your vertical asymptote, we have x minus 4. Let's explain. X minus 4 equals 0, so x equals 4. Okay. For horizontal asymptote, we're using x over x. When you reduce this fraction, you get y equals 1. For the holes, we canceled out x plus 2. So we set that equal to 0 and solve. So we're going to get negative 2 as our x value of our hole. We put that negative 2 back into our equation. So negative 2 minus 1 over negative 2 minus 4 gives us negative 3 over negative 6, which gives us positive 1/2. So negative 2 and 1/2 is going to be our hole. Make that bigger. Okay. And then last, for our sign analysis, we have two points and a hole on the left, but nothing on the right. So we're going to put a 5 in for our x value. So we have 5 minus 1 over 5 minus 4, which gives us 4 divided by 1, which is 4. So if we do 5 comma 4, that's our other sign analysis point. Now we have points on both sides. We can graph it. Again, make sure you don't put the line through the hole. All right. All right, last 3. So in this case, again, we can factor things out. We have x plus 4 and x minus 2. On the bottom, I'm going to take that negative out with the x as a greatest common factor, which means I'll be left with x minus 6. Okay, well now we have a situation where we don't cancel anything out after we factored, because there's nothing to cancel. That doesn't mean the problem's wrong, it just means there's going to be a little added difficulty to it, but it's the same process, okay? So if we go through this, for the y-intercept, we're still putting zeros in for the x's. So we have 0 plus 4 times 0 minus 2, negative 0 times 0 minus 6. Now, what this can show you is that the 0 on the bottom, because it is being multiplied, that's going to give you 0 on the bottom of your fraction, which you can't have. So you have an undefined, which means there is no y-intercept. Okay. For the x-intercepts, we take the top, the numerators. We set them equal to 0. Well, now we just have 2 of them, which is fine, which means we're going to have 2 x-intercepts, which is fine. So we're going to have negative 4, comma 0, and positive 2, comma 0. Okay, just because there's 2 of them doesn't mean we can't have more than one x-intercept. So we have negative 4, and then positive 2. Okay, your vertical asymptote, we take our denominators and set them equal to 0. This time there's 2 factors there. We have negative x is equal to 0, and x minus 6 is equal to 0. We solve them both. So we have x equals 0, we divide by -1, but 0 divided by -1 is still 0. And then we have x equals 6. Okay, so we're going to have 2 vertical asymptotes. All right, this also makes sense when we're doing these problems. When we have our vertical asymptote on the y-axis, that makes sense why we don't have a y-intercept. Okay. Our horizontal asymptote. We're actually going to go back to the very beginning of this problem to find a horizontal asymptote. Remember, it's the leading terms in your problem. Well, these are the leading terms. X squared over negative x squared. Well, x squared over x squared is 1, and one of them is negative. So that's going to give you -1. So this is our horizontal asymptote at -1. Okay. Holes. We didn't cancel out anything, so there's no holes. Okay, and sine analysis. It works the same way. We're looking for points or something on all the different sides of our graph to be able to graph it correctly. Well, we have 2 asymptotes now. So we have a point to the left of the first asymptote. We have a point in the middle of the 2 asymptotes, but there's no points on the right-hand side of the farthest asymptote. Okay, so we can find that value. Now, we have 6, 7, 8. We have 7, 8, 9, and 10 to choose from. Let's just pick 8. I don't know why. I'm just going to pick 8. So we put 8 in for our point that we're going to use. So we have 8 plus 4, 8 minus 2, -8 times 8 minus 6. Okay, so we figure out what that is. So 8 plus 4 is 12. 8 minus 2 is 6, so 12 times 6 is going to give you 72. And then -8 times 2 is going to give you -16. So 72 divided by -16 is, I'll make it a fraction because I like fractions better, -9 over 2, which is -4.5. Okay, so we go back over here. We go to 8. And then -4.5, which is going to be right about there. All right, so now the graphing can be a little more difficult for this because it is with the 2 asymptote, it is slightly different. Same kind of rules do apply. So we're going through the points and have to be bounded by our asymptotes. And then there's one other rule that we'll tell you about in just a second. So here's our first graph. All right, but now the problem is we have a point there in the middle, but where does it go? So here's one of the rules. Wherever you end your graph, going from left to right, which is we ended at the top of our coordinate plane, right? So that means the next time when you start, it has to go the opposite side. So this one has to start at the bottom. But we have that asymptote, that horizontal asymptote, and the point is above it. This is one of those times where I said at the very beginning when we did the notes, there are times where you can go through a horizontal asymptote, although you will never go through a vertical one. So we're going to go through the asymptote to get to the point because we had to start at the bottom. Now here we ended at the top again, which means we had to start at the bottom the next time, which makes sense because we're going to be here. Now it's going to be bounded again by our 2 asymptotes, the vertical and the horizontal. So this is the way the graph should look. All right. Number 5. Again, we're taking out a greatest common factor of x. All right, now on the bottom, we're going to take out a 2 first. I'm going to take it out over here as a greatest common factor. And I'll get this. Okay, so now I can factor that x squared plus x minus 6, all right, on the bottom of my factorization over here. So we have x plus 3 and x minus 2. Oops, there's an extra parentheses there. We don't need, we'll erase that one. All right, so again, we have a situation where we're not going to cancel anything out. So that means there's no holes, but it also means there's going to be a little more complication like with the last question we just did. All right, so putting in 0 for the x's. All right, again, it seems like a complicated thing, but if you look at the top, we have 0 times something. 0 times anything is 0. You can't have, you can have a number, but 0 divided by anything is just going to be 0. Okay, so it's not undefined because the 0 is not at the bottom, it's on the top of our fraction. All right, but 0 out of 10 or whatever it might be is still 0. So we're going to have 0, 0 as our y-intercept. Let's graph that out. All right, for your x-intercept, all right, we take the numerators. We have two of them. So we have x equals 0, and we have x minus 4 equals 0. We solve them both. So we'll have two x-intercepts. We're going to have 0, 0. We're going to have 4, 0. Well, 0, 0 is already graphed. And we got to do 4, 0 right here. For your vertical asymptotes, we just need the factor parts that have a x in them. So we have x plus 3 equals 0. We have x minus 2 equals 0. So we will again have two vertical asymptotes. X will equal negative 3, and x will equal positive 2. And then go to 2. Okay. For horizontal, we're going to look back at the beginning of the problem first. We have x squared over 2x squared. So we have x squared over 2x squared. The x squared will simplify into just 1. So your horizontal asymptote will be y equals 1/2. It's an ugly 2. Sorry about that. There we go. All right, so it's just going to be right here. Okay. There are no holes because there's nothing that got canceled out. And our sine analysis. Well, now we have a point to the far right, a point in the middle, but nothing on the left. Let's use our negative 5 that we like to use. Well, at least I like to use it. So we have negative 5, and then negative 5 minus 4. On the top, we have 2 times negative 5 plus 3, and negative 5 minus 2. So on the top, we're going to have negative 9 times negative 5, which is going to be positive 45. On the bottom, we're going to have 2 times negative 2 times negative 7, which will give us 28. So can we do 45 divided by 28? It's 1.6. Let's see what the fraction is. Oh, it doesn't change. That's ugly. So 45 over 28. That is ugly, but whatever. Okay, it still works. It's like 1.6, so it's about 1.5. So if we go negative 5 and 1 and a little bit, there's our other point. Okay. All right, so in this case, when we're doing the how it starts, again, here left to right, go up. All right. Then here, because that point's on the bottom, our graph's going to have to look like this on the far right side. And if it stops down here, that means it's got to, or sorry, if it starts at the bottom on that third section of our graph, it's going to have to end at the top. And if the other one ended at the top, it has to start at the bottom. So we're going to again go through our point and our asymptote for our horizontal. Your graph's going to look like this. Oh, I got some more. There we go. All right, last one. We have x plus 3. We factor out an x, x minus 3. So for our y-intercept, we have 0 plus 3 over 0 times 0 plus 3. Again, since we're multiplying by 0 on the bottom of our fraction, that's going to be an undefined, so that means there is none as far as our y-intercept is concerned. For the x-intercept, take our numerator, x plus 3, set it equal to 0. We're going to get negative 3 comma 0. For our vertical asymptote, we take our denominator. This time, again, we have 2, so x equals 0, and x plus 3 equals 0. Did I do that right? Oh, it's minus 3, sorry. Change that real quick. So this is minus 3. Okay. So then our two vertical asymptotes will be x equals 3 and x equals 0. So we have, and this again makes sense for there's not being a y-intercept because there is an asymptote on the y-axis. Oh, all the way to the top. Hold on a second. There we go. Sorry about that. Okay, your horizontal asymptote is x over x squared. We're going to go back to the beginning. Okay, so we're going to have 1 over x. So let's put it this way, x over x squared gives you 1 over x, which is going to be 0. Oops, sorry. It's y equals 0. All right. Your holes, you know, they can get canceled out, so it's going to be a none. And your sine analysis. Well, we don't have a lot of points here. Oh, sorry, I forgot to put the horizontal asymptote. Now you're going to notice there's a point on our horizontal asymptote. Okay, we're going to deal with that in a little bit. For right now, let's do the sine analysis. Actually, we're going to do a few sine analysis for this problem because it's a little bit tricky. We're going to find points in a bunch of different spots. All right, we're going to actually find a point to the left of the asymptote because of the first vertical asymptote because our point is on the horizontal asymptote, which is a possibility. Okay, so let's actually do -5. We're going to do a couple, oops, yeah, there we go. -5 plus 3 is our first one. And we're going to have -5 times -5 minus 3. Actually, you know what? Let's put this off to the side because we're going to do a bunch of these. So we're going to have -5 plus 3 over -5 times -5 minus 3. So we will get -2 on the top, and then positive 40 on the bottom. So 2 divided by 40 is going to be 0.05. So we're going to get -5 and -1/20th. Okay, this is going to be an important piece, and I'll tell you why as we go through this. So our sign says -5 is going to be a negative number here. So what that means is our graph, when we graph it, I'm going to just start this part first. When we graph it, it's going to start below. It's going to go up through that point on the horizontal axis and go up. Okay, that's what that means. So if it had been, if that point that we just found at -5 was above the horizontal axis, or asymptote, sorry, it would go through, I'll do it in red. It would go like this. Okay, but it wasn't. It was at the bottom. All right, go back. All right, let's find the other points, the one in the middle. Let's pick 1. 1's a nice, easy number to use. Okay, so we have 1 plus 3, and 1 times 1 minus 3. So we'd have 4 on the top. That's -2 on the bottom, which gives you -2. So we have 1 comma -2. All right, and let's do the last side. Let's pick +5. So I have 5 plus 3. On the bottom, we're going to have 5 times 5 plus 3. So we'll have 8 on the top and then 40 on the bottom, which will give us 1/5. going to be here. Okay. So now, here's the thing. Let's do the far side first, because it's going to be bounded by the asymptotes, the horizontal and the vertical. Now what this means is if both of these end or start at the top, that means this one's going to go up, and it's not going to go through the asymptote this time. It's going to bounce off it and come back down. Okay, I know that seems a little bit weird. The good news is if you can do these problems, it's a good challenge. These are the harder ones, will not be on the test. It's just going to be the ones that we did for the first practice and the top 3. But these are problems that show up with these fractional equations. If you were, let's say, in honors, you'd be doing these more often. But this is a good way to just introduce yourself to a little bit harder the math and just challenge yourself to try a little bit harder problems. All right? So hopefully you've done the practice for the first and the second one. And if you're having problems, you've watched the video. If you have questions, make sure you please ask during a Zoom session. And good luck.